Now we're going to use the calculator to see what happens here. So we're going to press log. Find the log. It's on 3 keys above the on button. Log. I got to turn mine on first. Log of -7. Remember, it's the negative sign, which is below the 3. And hit enter. And what does it tell you? Notice there that the calculator says error, non-real answer. Error. That's what it's saying. Non-real answer. Why does it say that? What's going on with that? Well, what's happening here is we could look at this a couple ways. We could say that log of -7, we could set it equal to x. Let me move our calculator for a second here. And we get 10 to the x equals -7. What can you raise 10 to get a negative number? There is nothing that you can raise that to, so there is no solution. Recall on the other side we had the graph of this log function. It looks like this. What was the domain of it? The domain was x was greater than 0. -7 is not greater than 0. It is not in the domain. We cannot find it. When we do the next one, type in, so we could just hit quit or enter. We'll type in ln of 1. ln is right below that log key. Move it up a little bit. ln 1, enter, and that gives you 0. This is just to make sure we can do this. ln of 2, and that gives you 0.69. Now the next one says ln of e. So what you're going to do on that one is type in, hit ln, and notice right above the ln in yellow here, there's e to the x. So we need to press second, e to the x, and notice how it says ln of e to a power. We're going to plug in 1, and then close that parenthesis up, and hit enter, and it gives us 1. There's another way we can do it, but we need to know this key on there, so I'll just use this. And this is 1. Now let's solve some problems. Let's use our transformation. What's the base of the log? The base is 5. What is a log? A log is an exponential. A log is an exponent, and so the exponent is here is 2 equals x, so x is 25. Similarly, we have the base is 7, the exponent, that's what the log equals, is 1/2, and that equals x. And you could say write it like that, or you could write it as the square root of 7. Here, this just says log of x. It doesn't have a base written down. What is that base? Well, like we said earlier, that is the common log, or a base 10 when it's not written. So we have 10 to the exponent of -1.2 equals x. Now you could type that in on your calculator, and if we were only going to 2 decimal places, it would give us 0.06. Now that's the approximate answer. And on this one, what's the base when we write ln, natural log? The base is log base e. So this is e squared equals x. Now that's the exact answer. So if we didn't have a calculator, we'd leave it like that, and we're done. If I said to round it to 2 decimal places, we would write it as 7.39 is approximately equal to x, because that's a rounded. Number 8, our base this time is x. Our exponent is 2 equals 121. We're going to solve this. We put our plus or minus. X equals plus or minus 11. Now, what do you think about that? Well, you have to remember that when we're dealing with these, the base has to be greater than 0, and the base cannot equal 1. So what that does is it throws out that -11 completely, and we have just one answer of x equals 11. Now I want you to go through it always when you're taking that square root, have your 2 answers, and then adjust when needed. Over here our base is x, our exponent is 3 equals 64. Now that is the same as 4 cubed, our cube root, and we know our answer is x equals 4. This time our base again is x. exponent is -1 equals 1/2. Now there's multiple ways you can go about doing this. This is 1 over x equals 1 over 2. And I think we've done this so far this year. If two fractions are equal and they're not 0, then their reciprocals are equal. So in other words, x over 1 equals 2 over 1, or just x equals 2. I'm just writing that intermediate step just to emphasize that I'm flipping these fractions. And the last one, x to the 1/2 equals the square root of 6. And I was going to say x to the 1/2 equals 6 to the 1/2, so x equals 6. I could have squared both sides to get x equals 6. Again, there's multiple ways to go about it, and that's it for this lesson.